Great. Thank you very much to all our speakers today. Those were excellent presentations. I'd like to open up now to the open question and answer period and invite anyone who's interested to post questions in the meeting chat. First question to Albert. The Earth MRI project is a major initiative underway at the USGS, which is a large number of new data acquisitions occurring across the country in a collaboration with the state surveys. How is this systems project and the sum inventory of the work you've been leading intersecting with the new data acquisitions?
Well, that's a good question. The systems and deposit classification scheme that we developed for CMMI is an outgrowth of one that we developed for the Earth Mapping Resources Initiative. And it was used so that we could assess all of the critical minerals that occur in a given system type in focus areas that correspond to individual systems of each type. So what we did was prioritize focus areas that correspond to systems in terms of, could we learn a lot there and is there potential? And those were the ones where we put our funds for geophysical surveys, geologic mapping, geochemical sampling. So the systems approach was integrated into Earth MRI in that way. I think that may answer your question.
Yes, great, thank you. Next, perhaps we move on to Simon. Australia recently announced in its 2022 critical mineral strategy $50 million towards a virtual critical minerals research and development center. Maybe you can comment on how Geoscience Australia will be contributing to this initiative.
Yes, thanks for that question. So we will be have staff involved in that project, and also money from that initiative will be used as part of the doing analysis of geochemical samples of ore deposits, so they will feed into the CME work and doing basically prospectivity analysis for basic critical minerals around Australia. I might also say that there's a part of that will go to help fund basic exploration as well. So there'll be if there's advanced projects, there's money going towards that.
Great, thank you. Mario, perhaps I can ask you a question. I guess excellent presentation, and it's been identified, that exploring undercover rocks represents one of the greatest technical challenges for identifying new deposits in Australia. And I'm just wondering, I wasn't able to see when the data products you were discussing today, when they'll be released or when they have been released, and how is that impacting exploration in Australia?
Thank you very much for your question. So most of the work I presented today was released as part of the first phase of the Exploring for the Future program. So most of the data has been released in 2020 and it's available on the portal. It was mainly focusing in Northern Australia. With this national scale project, we are now focusing a bit more on the southern part. So we are progressing this work and we will be releasing data as we go. With the latest release in June 24. That's the end of the program at the moment. Does that answer the question?
Yes, great, thank you.
Thank you.
Next, I maybe move on to Louise. Louise, thanks you for giving the great overview on metasomatic iron alkali calcite ore systems. That's just a quick question. In general, we see a lot of these, all the known deposits are discovered in unmetamorphosed terrains. And I'm just wondering what your comments are on the mineral potential in metamorphic terrains and perhaps what will happen to these systems if they get metamorphosed.
Well, that's a very important question indeed. We were very fortunate in Canada to work on non-metamorphosed systems, such as those of the Great Bear Magnetic Zone. But I also have extensive experience in high-grade metamorphic terrains, and I've always, when I map non-metamorphic terrains such as the Great Bear, in my head, I metamorphose them in granulite facies and vice versa. So we have developed a lot of tools where if you have units that are very atypical in terms of mineral contents, the first reaction is often to think that they will be restite. So if a rock has too much garnet, we'll say, oh, it has enriched in garnet because it was a restite, or if it's the same thing for sillimanite. However, if you model using AFM diagrams or the more sophisticated Perplex and Thermocalc program, if you model the chemistry of alteration zone and you metamorphose them at granulite facies, then you will be getting garnetite, you will be getting sillimanite quartz gneiss, you will be getting tourmalinite and all sorts of very, very important indicator units. And then you take that, you sample them, you do the geochemistry, and then you reverse model to see what kind of alteration type you could have and what kind of mineral systems you can have and what kind of mineral deposits you can have. So that exercise really needs to be done for every deposit type that we know of, and mapping the Granville province has been extremely informative because we have found ROCG type mineralization and iron oxide apatite type mineralization at granulite facies using those very atypical rock types. So when somebody has a restite model, the other model of metamorphose alteration zone should be also investigated because in many cases, that's what they are. Thank you.
Great, thank you, Louise. Next, we have a couple questions actually for Omid from the chat. First one was, do you have any microanalytical data for apatite in the high rare earth element layers and the high phosphate horizons in the shale, such as we saw at the Gordondale units?
Thank you so much. This is a great question. As I mentioned, it's the first year of the project, and we have a lot of actually issues with doing the speciation analysis. The next step would be those microanalysis. That at this moment we didn't do any kind of microanalysis on those phosphatic layers, but it is in our plan actually to the tune or the extraction method, probably add some kind of other minerals to extract. For example, Gordondale have a high concentration of the calcite minerals as well. We want to add those kind of speciation as well. But the short answer to your question, no, we didn't actually did so far.
Okay, great. Another quick question from a background as a uranium deposit geologist. I'm always curious, has anyone, I think there's been some historical work, but looked at the uranium contents in some of these phosphatic shales or other critical metals that we could use to offset some of the processing costs or difficulties?
Because the major focus was on rare earth elements, we didn't actually look at other elements. But for your information, Gordondale is a highly metalliferous shale. In some intervals, for example, we have in the range of percentage of zinc, molybdenum is very high, and the other elements. But definitely, it's going to be the kind of frontier for us to look at those the elements in this shale. I don't actually remember at the top of my head what was the high concentration of the highest concentration of uranium in those shale, but all of those elements, including molybdenum, vanadium, and the cadmium, also have very high concentration specifically in Gordondale.
Great, thanks very much. Next, perhaps we'll move on to Craig. George Case. Graphite, as we know, is expected to make a huge growth in the next few decades, but the deposits are really challenging, as you showed today, that they're very small footprints on surface. Just curious, what sort of exploration technologies are being deployed in Alaska to look for these systems?
Hi, right now, aerial electromagnetics are probably the the most commonly used tool to explore for those. The carbonaceous or graphite bearing horizons really respond well to that type of tool, and it's the graphite one has done some local surveys there, I believe, and it outlines the mineralization pretty well, and there are potentially more regional surveys that could be flown or conducted to highlight those horizons. So they do show up pretty well with that method.
Great, thank you very much.
Thank you.
Great, thanks. I'm just taking one last look at the chat here. I don't think there's any outstanding questions. I just want to once again thank you to all the speakers for volunteering to present your research today, and I invite anyone who's interested to contact any of the co-authors. Also, I'd like everyone to stay tuned for the initiative. We'll be doing periodic releases on the websites, so stay tuned for all the next developments in this exciting initiative. Thanks very much, and once again, thanks so much to the American Geosciences Institute for hosting this forum today.